Hello, everybody, and welcome to this introduction and overview session in the certificate programs in Python for algorithmic trading, computational finance, and asset management. My name is Yves. I'm the CEO and founder of the Python Quants, as well as of the AI Machine, and I'm also the program director. Yeah, I'm pretty excited that we get started with the January 2022 cohort of our certificate programs. As always, I can say we have many new things that we want to bring to the program. So the program has been growing over the years. So we're adding more and more valuable content so that you are better able to navigate the world of Python for finance and that you are better able to acquire the necessary skills in order to strive in this world, this exciting world of financial data science and also AI for finance and all the fantastic topics that we are going to cover today. Yeah, this session is roughly 2 hours long, and I have prepared an overview and agenda. After a quick introduction of what we do and what the program is all about from a really high level perspective, I want to quickly show the Quant Platform. Then I dive into the single classes. Mathematics Basics is one of the largest classes that we have ever had. So this is a class that is meant to bring you up to speed with regard to the mathematical concepts that are required, as well as to the basic Python concept. So it's a little bit different in style to the other classes, but more on that later on. We also have added recently Crypto Basics class. Finance with Python is a very fundamental class. Tools and skills, as the name suggests, is about the necessary tools and skills that you need in order to apply the content and the techniques that we show in the other classes. Python for financial data science, I would say, is a core element because it provides you with necessary techniques, approaches that are so useful in the other classes. Python for Excel, as the name says, dedicated to those who are using still Excel or might have use cases where Python might come in handy instead of VBA, let's say. Python for databases, yeah, of course, we need to deal in finance with large data sets these days. And here we cover techniques and technologies that are well suited to work with large data sets. Natural language processing, it's just like still a smaller topic, but we cover very important and very useful things in this class. So I also have prepared a little use case for today. So bear with me later on. You will see and hear more. Artificial intelligence in finance is now at the core of our program. So we have lots and lots of content in this regard. And one of the special topics here is reinforcement learning for finance. Also pretty exciting, in particular for those maybe like myself who are have been growing up with games. I mean, these days my son is playing games here in our house, right? So that's today, but still, it's kind of nice, even if you're not playing yourself, but you can develop trading bots or playing game bots, right, that play the games for you. And finance trading can also be considered a game in this sense. And you can design finance bots that trade automatically in the markets. This is also a nice topic and an exciting topic, I think, in our program. Then Python for algorithmic trading, for computational finance, and for asset management. These are the three core classes. Many of you have decided to go with what we call the Platinum package, which means you have access to all of the core classes as well. That's quite a bit. I usually recommend, and I will repeat this later on, that maybe in the first go you focus on one topic and later on you cover the other topics. But if you have time enough, maybe during a sabbatical, let's say, you can of course study all the elements. Case studies and demos is meant to whet the appetite. Nothing that we're going to do today has anything to do with training, learning, education. It's more like giving an overview, right? So I will show quite a bit of code, but I won't go into the details. It's more like that you get a feel for what to expect in the different areas here. Study plan, something that I want to discuss as well. So how you shall treat it, what is meant by the single elements that you find there, etc. Some guiding principles. That's just one slide, but I think that's important to understand what guides us, what guides me in like designing the program. Reviews, exercise, and test project. This is where you need to become active because skill acquisition is the primary focus of our program, and you should do stuff on your own. So it's like when you want to learn the game of chess, you can read like 10 chess books, but there comes a day when you need to get at the board and need to move the pieces around, right? So, and this is the same with coding. It is a skill after all. It's nothing that you can acquire by reading or by watching. The user forum and the Discord server, these are our two main means that we use in order to support you. The user forum is primarily dedicated for technical questions with regard to code, with regard to content. There you have the opportunity to, let's say, upload code and to upload and attach, let's say, Jupyter Notebooks with your code and the problems. And you can also have syntax highlighting when you paste code. All these elements are well suited to pose technical questions. So the Discord server that we run and maintain is more meant for everything beyond that, right? When you have an organizational question or you want to discuss with other delegates in your cohort or in other cohorts, this is then the right place. We will also have regular Discord sessions, so scheduled sessions beyond what might be going on a daily basis there. Of course, these servers these days are open 24/7, but in these sessions you can then ask specific questions that I or others we'll try to answer as good as we can. Yeah, it's quite a bit on the agenda, so let's dive into it. And you shouldn't try to, how shall I say, to follow along every single element in detail. So I will present quite a few things today. And again, this is more for an overview. There's an introduction and an overview. When I show code, for example, or do a little bit of coding or go through the Quant platform, please do me and yourself a favor and lean back and just watch and maybe revisit it later on, the recording on the Quant platform. So this usually takes a few hours, and then the recording is available on our Quant platform, and then you should try it if you like on your own. But now please listen and watch carefully. That's, I think, much more productive than trying to do anything that I'm going to show, because this is just distracting you from the main messages that I try to convey. So, introduction. For those of you who don't know yet, we do quite a bunch of things, but our core is Python for Finance at the Python Quants, and this for quite a couple of years now. We provide services for larger financial institutions, training, of course. This is where here our certificate falls into on the right-hand side at certification, where we are proud of that we can provide a somehow established certificate for 3 different topics, algo trading, comp finance, as well as asset management. We run platforms like the AI machine for trading, like the Quant platform itself, which is the main go-to resource for you during the whole program. We have open sourced a couple of libraries. I've written a bunch of books, and we run events as well. So we used to do this live in, let's say, New York and Frankfurt and London, Berlin, Paris. Then the new situation hit, and we have done a few of them recently in digital form. I hope to get back to the live and on-site events in 2022. Yeah, the other project with the dedicated team in India, out of India, Hyderabad, is the AI machine. This is an AI-powered Python-based trading platform. The idea was to solve the last mile problem in algo trading, so you can formulate your strategies in Python, be it ML-based or technical or whatever. Then you do a backtest, and basically with a single click, a one-click, can think of it like one-click shopping that Amazon introduced quite a while back. You can deploy the strategy in the cloud here based on the platform, and it runs. So that's the other project. It's not probably of interest to everybody, but it's something that kept us busy as well over the last few years. So my most recent book, I must say, this came out towards the end of 2021. It's Financial Theory of Python. That's basically the introductory book. I've written a total of 6 books in this context, but here is the introductory book. The last one is the most basic one, if you like. If you like, that's the main source to like 90% for the finance with Python class, right? The title was changed here to Financial Theory of Python. It covers the very basics of both finance as well as Python. Python for Finance, maybe I can say my best-selling book. For sure, it has the largest numbers sold. It was translated in many different languages. Here, see the Japanese version of the second edition. It has been translated in Chinese, and it's used around the world by practitioners as well as by academics and students, which makes me even a bit more proud that the topic that I've been working on for so long is now also part of many curricula around the world at finance departments and in finance programs. So the quant finance side here, this is where I personally am coming from, a PhD with a mass finance, financial engineering. And here you see my quant finance books that use intensively Python, obviously. They are not teaching Python, they just use Python. And these are the basis, these two books for the computational finance classes, right? So these books have coming out in 2020, Python for algo trading. You might have guessed it. That's today the basis for the algorithmic trading class, but the sequence is the other way around. So the materials have been developed as a class, and later on this was published as a book. Same holds true for AI in finance, which, as I said before, has become such a core topic. And here you see the outgrowth now as a book. But of course, we have many, many more materials in both areas as compared to the books. And not only, let's say, the videos that come on top of that, they are also in both of these areas and fields. We have many, many additional resources, lots of code, many, many more notebooks, etc., that the program comes with. And here I don't know, it's a long CV, but that's my CV. If you're interested in, you have access to the slides, of course. I'm not going into the details here. So the program, now that I've mentioned it so abstractly, here we see it's 16 weeks. If you need more time, that's not a big deal. I know there are others out there who say, well, you have access maybe for half a year or 4 weeks after the program ends. With us, you have basically indefinite access to all your personal resources. This might not include stuff that we come out with in the future, right? So it's like when you buy a Tesla car and Elon Musk comes out with another car, it's not included in your recent transaction, right? But everything that you have, and if maybe there are updates, every once in a while we update every class, right? And then you will benefit from that as well in the future. So thousands of lines of code, many Jupyter notebooks, many pages, and many hours of instruction. So the program has grown over time, but I have still kept the length of the program as it was in the beginning, 12 weeks plus 4 practice weeks. So sometimes people say, well, if your program is more like a complete master's program. And actually, here at the beginning of 2022, I can agree to that. It's really ambitious to finish a program within the 16 weeks, but you can, of course, prioritize, and you don't need to cover everything, not even everything that's in the study plan, in order to be successful here in the program. That's just another view with a few more elements, right? The message is the same. Lots and lots of content, lots to study. And if you say, well, I try to focus a little bit more in the first round, 16 weeks, you still can study for the rest of the year, basically, if you like, and go deeper into different topics. I've got feedback over time where people say, well, this was so nice and my final project was so exciting and I learned really a lot, but I skipped X, Y, that. And this is something that I'm going to cover on, let's say, in the next month or 2 or 3, right? So nothing speaks against that. I'm aware of the fact that there's quite a lot to cover in our program. So why do we do this after all? Yeah, because times have changed in the financial industry, and not only yesterday. Here, that's the reason why I keep this article here. It's from 2018 already, right? So JP Morgan's requirement for new staff, coding lessons. And what coding lessons? Here in the lower right-hand corner, the coding training for this year's juniors was based on Python programming, which will help them to analyze very large data sets and interpret unstructured data, such as free text language. Next year, the asset management division will expand the mandatory tech training to include data science concepts, machine learning, and cloud computing. Basically, every buzzword that you read here is covered in detail. Many details covered in our program. So I think the program is still timely. And of course, we add more and more things as we go. Just think of the new class, Crypto Basics, for the so important crypto world and Web3 or whatever you want to call it these days, right? So of course, times, markets and industries change, and we try our best to keep up with what is going on. Of course, technologies change as well. So I credit with tech and finance skills, and I think this is also something that is pretty special in our program, because everything that you will experience in our program is always at the intersection of tech and finance. So computer programming skills are becoming a must-have. Don't bother putting Excel or PowerPoint on your resume. Financial institutions are looking for R, Python, and or other programming languages. I don't think that R is still required these days, maybe for some very specific statistical, maybe some machine learning programs, but still Python, even in the machine learning world that I just mentioned, Python is without a doubt the #1 programming language, and our program is really at the intersection. If you want to chart a Venn diagram, it would be indeed tech. It would be tech meaning Python. It would be finance plus AI, machine learning, right? And this is, I think, what differentiates our program. We don't have any theoretical finance classes, nor, let's say, pure technology programming classes, right? It's not a computer science degree. It's kind of like at the very intersection. You can think of it a little bit like in the old days. I'm a big martial arts fan and doing martial arts myself. In the old days, there was like, let's say, judo, karate, wrestling, boxing, etc. Right? And these days we have MMA, and people train MMA. Right? They don't go to the one gym. Sometimes they might do, but the new generation, they really train MMA with different trainings that they have over the course of the week. And this is how I see it here, right? We are jumping right into it, fully integrated and not somehow separated in that sense. So the Quant Platform is basically something, that is really at the core. You will visit the platform over and over again. That's basically your #1 resource where you find everything from the code, from the Jupyter Notebooks to the videos, to the text, to like everything. And you should get well versed with the platform itself. And I want to illustrate this briefly. There is here also a link to the video. Everybody should have received the link to the overview video. This will be updated shortly because we have added quite a bunch of powerful new functions and functionalities to the platform. So there's a need to update it, but the basic functionalities are explained in this notebook. But I want to briefly demonstrate this based on, for example, the mathematics basics class. So I said that this is now the largest class. We have, as it stands right now, 39 modules are about 1 hour. So this is like a program in and of itself. But you see, it covers very basic things. But if you put the very basic building blocks together, you have mastered already quite a lot of very important things for the other topics. So if you go through it, it is not on the study plan, as I said before. If you go through it on your own, some of you might have started with it already. You have a very good basis to move on from there and to then dive a little bit deeper, let's say, into financial data science or the other topics that we cover there. But math, if you like it or not, or if you liked it back at the university, college, or at school or not, it's simply something that you need for data science and for finance as well. But when I now say you should study this on your own, how does it look? Where do you find the thing? So let me open the Quant Platform. Everybody of you should have access to it. So that's not the one that I want to log in here. Eve is my main account. And when I log in, that's like always the same thing, right? When you want to show something, things are going wrong. I can maybe do this a little bit later and ping my. Actually, I think in the last intro and overview, the same thing happened as well. So let me give it another try. I said you shouldn't try to follow along, so please don't bother with. Yeah, now I'm logged in, right? This was maybe just a everything because I changed the user. I can show you I have quite a bunch of users here. So there's like, and sometimes the platform, you should just have one account, but I have so many and I changed from it. So this can always lead to certain issues as you could see. So what do you see here? That's what we call the dashboard. And in the dashboard, the first thing that you see are the latest videos. So you see the 3 latest videos that have been uploaded to the Quant platform. So the last video was crypto basics. So then we have the math basics and AI first finance. This was a talk that I've given at a virtual conference. Yeah, you see here you can directly go, for example, to crypto basics. When you click on the header, then you see here the sessions that are there so far. This is not what I want to focus on. Mathematics basics, the same. You can also from here start immediately the video, right? If you say, well, I want to jump into the latest or the second but latest video, this works as well. So you can navigate here, right? We've also changed the video players, so you can speed up things here, for example, by a factor of 1.5 or 2. I don't know if 3 or 5 makes sense. And again, this holds true for the same thing, but I want to focus here on math basics. So under trainings, you find basically the core classes. We differentiate between courses and trainings. Courses are usually text plus code, and trainings, they all have video, right? Here you see crypto basics from before or math basics. So I could now get to the latest one here via the latest video, or I click on math basics and it opens the mathematics basics class, right? And when I go down, you know by now, no surprise that we have 39 modules here, and we are planning to add quite a few more. So we cover the basics with Python, basics with NumPy and SciPy, as well as basics with Pandas, plus also SymPy for symbolic mathematics. So there's quite a lot of content is in there. Say you want to get started, and you see here the first video. Of course, I would start at the beginning. It's not really necessary. So if there are topics, and you can read here the topics that are covered in the different classes, right? You can also search the platform for such topics so that you find, for example, modules. You can jump right into it, but some of the sessions are sequential and built on top of each other. So where stuff is reused or where there are a bunch of references or whatnot, yeah, that's the case, but no real need to do so. Also, no need to try now to get through all the 39 at once. Be relaxed and focus rather on the study plan and fill in the gaps here with mathematics basics. So you might want to get started here with watching the video. I usually recommend that you get started with the video first, that you focus on what is presented, on what is happening there, what I'm talking about. Again, you can go, for example, and say, well, I understand this better when it's a little bit faster. So I always hear podcasts with 1.5 or 2 times the speed. So you can speed this up, right? Even up to 5 if you want to get a quick overview. Probably you won't understand anything anymore, right? But that's not probably then a big deal because it's about code. And when you got through it once, I mean, if you have, for example, 2 screens, you can have open Jupyter Lab as well. But again, my recommendation is first go through the video, try to understand what's going on, and then enter the coding side itself. I think that's, yeah, from my point of view, the most productive way. Then you say, oh, okay, it's all good. And for example, here, you also see the link to the slides. Usually for these classes, there's just a few slides that I use here, right? Not too many that are used in the session. And you can then also click on a Jupyter Notebook, for example. This opens Jupyter Lab. This takes a bit because this is all Docker based. So we fire up a Docker container for you. And you see here, that's the notebook that I was using in the module. So we just changed to the Jupyter Lab dark theme. There are two standard themes. These days, I prefer dark everything, also on my phone. You can, if you prefer it a little bit lighter, you can, of course, go with light as well. But by default, we have just changed to dark. So, and there you now see code. I mean, in the beginning here is not that much code, but it's Python in the sense that the interpreter can understand it, and you can go and execute here the single cells. What I'm using now is shift return to execute it. You see here that the circle, if you have worked with Jupyter Lab, doesn't change to a cross, meaning that a cross would mean that the notebook is saved. And when you go here to the file menu, you see that save notebook is blanked out. Save all is also grayed out, not blanked out, it's grayed out. The only thing that it can do is save notebook as. What is the reason behind that? So I want to emphasize this because this is a very important aspect here of the Quant Platform. We provide you here with let's say the originals. Everybody has access to the originals, and these are read-only files. So all the files that you have access to here on the Quant Platform in the beginning are read-only files. So you get access, everybody gets access to the same file. So you cannot override it and somebody else accesses it, what you have been changing for the file. So that's not how it should be. So it should be that everybody gets access to the original stuff. But you can, of course, once you have done some changes, right, and you want to save the changes, or you want to, I don't know, copy things together or whatever you want to do with it, you have basically two options. The one is that you say download. You can always download stuff. So we have no login here. Login that we say, well, we provide here resources that you can't put on your own machine. This is not what we want. We are open. So these are your resources. You can work with them. You can download them. But there are licenses, or you cannot share them with others, with the outer world, right? Just to emphasize it. So you can download it, but you can also stay here on the Quant Platform and you say, for example, save notebook as, and here you see now a path, and the path might be pretty long, right? This is now the whole path to where we are, and I see Mathematics Basics 1. I simply delete here the path. I could also change a path. I can create also my custom folder structure, if you like. But what is read-only here can now be written into a folder, and I write it here in my quote-unquote root folder and save it, this version. And now I need to get back here in Jupyter Lab, and you see, like magic, I have now 01 math, and I can now go and here change stuff. These are my own changes, right? And maybe I make this a header, right? And now I can, when you look at file, I can now do save notebook, and the changes are saved. So be careful when you open files, notebooks like I did before. Check if this is read-only. Usually it is, right? So you need to create a copy on your own, and then you can work with the files and you can store it here. You could also see, as you see, for example, here, data store. These are custom folders. I can, via right-click, also create a folder here, right? And then I could, for example, put this thing here into folder. This is now running. Probably you wouldn't find it anymore. Just to show how to work. It's full-fledged Jupyter Lab. You have basically all the functionality that you might need here. So if I don't need this anymore, right, I can go here and shut down the kernel. I can delete this file because this was a copy, right? Remember, the other file that I've opened was read-only, so I can't mess up with this file. The folder is empty, and I don't need anymore. I can delete the folder here as well. You can also upload files here with the upload button. If you have something locally, you can upload it, a data file or whatnot. And you have also a, let's say, full-fledged editing capabilities, like here, where I've now created an untitled text. So I can change this now, for example, to test py. That it says that it's now a Python file. You see the icon changes. So here, simple test file. So if this is all too small, you can, of course, in your browser increase the zoom in, or you can here increase terminal font size, or we have here increased text editor font size. So this is then working relative, and I can do things like import numpy as np from numpy random import default rng default, this was wrongly spelled, default are also rng, and random numbers are rng standard normal. Let's do some 50 and print rn. So we then have a Python file edited and saved. And what do we do with it? We have seen that we can execute code in Jupyter Lab, but what do we do with it now? Yeah, here from launcher we might want to open terminal, and that's a full-fledged terminal, meaning I can use all the Linux capabilities. And you see here the terminal font size is also relatively small. Some people like it, so I have here a relatively large screen. I would increase it maybe a bit, and I can now go and, for example, run Python test and see if it works. And indeed, it works. So it has imported NumPy. We have created random numbers. We are printing them out. And if I'm happy with it, that's fine. If not, let's say I want to have these numbers rounded to 3. I edit it here, go up, and then I get a little bit of a nicer output. Just to show we have editing, we have here the capabilities. So for example, we have a Git here. So the wonderful and powerful Linux tools are available on the Quant Platform. And also, if you want to have a look at the resources, htop here, you see in the Docker containers by default, you have 8 gigs of RAM for CPU core. So depending on what's going on, this might change, but currently you see here when I fire this up, this is what I've got. So that's for the command line, that's for the editing. If you want to keep these files, keep them. If you don't need them, I or you can delete them. So this is to get started with let me move this around here with the class, but I can also, said before, here go to Jupyter Lab directly. This was indirectly. So when I say directly, I mean not going via click here. So you can also open Jupyter Lab here and then go to certain files, right? So when I go up here, go to trainings, and then you see I have obviously access to all the trainings. That everybody might have the same folder structure here, mathematics basics. There you see also files, folders first. Files are in the folders, and here you see also the 01 mathematics basics, which is the same actually, but I just used another way, another mechanism to open this particular file. You see, this is again read only because it's the same file as before, just another way of getting to the file. So we need to be careful here again with changes, etc. So here it says discard changes. Yeah, I haven't done any changes, so it's easy and safe for me to discard the changes. For other classes, like, let me go to my slide deck. It is very similar. So for the crypto basics class, very same functioning, right? You have here the video, you have a link to the slides, you have here something else. You have, for example, sometimes linked to the gist where the resources are hosted in a different way. But this module, as you can see here, looks basically the same, but there are 3 Jupyter notebooks. You can click on them, and then you can open here, let's say 11 crypto basics. This is about signing messages with hashes and RSA keys. Pretty important in the crypto space, right? So that's basically the same structure, the same handling as the mathematics basics class. And here we cover topics such as hashing, encryption, um, blockchain, mining, smart contracts, and currencies themselves, right? So, but this class is at the start, and as we go, we will add more and more topics to it. So finance with Python is slightly different because here we have both cores with text as well as the class. So slightly different. That's the reason why I want to focus on it again a bit deeper. Gentle introduction, static two-state economy, fundamental theorem of asset pricing. So here we dive into what I would consider the very basics of finance, that everybody who is doing something in finance, whatever it is, not necessarily related to Python programming, but what everybody should know. And Python, of course, is used as the major tool to illustrate the elements. So here we do real fundamental finance stuff in this part. And when I said this is slightly different, yeah, here we have a class where there is also a text, let's say a book, but the text is presented in general as an HTML document. The videos and the Jupyter Notebooks, etc., they are the same, but we have a text as well. Now you might wonder, where do I find all these resources? Here on the Quant Platform, so we have courses, and there is finance with Python. Also in the study plan, you will see sometimes reading assignment, not sometimes, I'd rather say for certain classes, there are reading assignments, and this is one of them, finance with Python, right? You see on the left-hand side, a table of contents, and some 6 chapters, two-state economy, three-state economy. This now relates to what we have seen before in the slide, optimality and equilibrium. Let's say we dive here into 4.3, just randomly chosen. There is now the math explained, the math and finance explained, and of course, from a certain point on, after everything has been explained, oh, this was maybe not the best example because there is a bit more math and finance up front than usual, and then we go here and illustrate everything by the means of Python code. And you see, this is all pretty simple, I should say. Sometimes not easy, like to grasp what's going on, but the Python code at least is simple. So there are other areas where you might see hundreds of lines of code in a single bulk, but here it's just like step by step, and everything single step is also explained. So you find many details, and more details in this fundamental class than you can expect, I must say, in other classes, right? But with the proper foundations, as you move on, you would need less and less details in this context, right? So not for every book that we provide and text that we provide, there is a PDF for download, but for some of them there are. So I cannot say this is like throughout the same. Here we also have a PDF, but it's not the exact PDF that comes as the O'Reilly book, which came out last year, right? This is something that we can't do for contractual reasons, obvious reasons, I guess. Yes, and even if this does not work, you can always generate your PDF for yourself, right? Like printing out this HTML page, nothing speaks against that, right? You can go and print, like either print it, right? It takes a while. You see 132 sheets of paper, or you can still loading the preview because it's so long, right? It's of course a full-fledged document, and you see this can now be printed as well. So you're from the HTML versions, you can create your own downloads, let's say, as well, or your print version. You can print it out directly here, or you can save it as a PDF on your fax. So this takes, again, now quite a while. Just a message here if you don't find a PDF created on your own. Yeah, that's the text, and it's not only the text, because on the Quant Platform in the where's my Jupyter Lab here portal. So when I go to the root here, there are courses, right? And Finance with Python has here 6 notebooks, and for the course here, this is like 1 notebook per chapter. I said Finance with Python, or the book as it's called with O'Reilly, is called Financial Theory with Python. And there are 6 chapters. Every chapter has its own notebook. So Finance with Python here for our course 1. And you see that's pretty short. Maybe dive into 4, what we had before. And you see here they are executed. Sometimes the notebooks are hosted, not executed, so meaning that there are no charts or whatnot in there. And yeah, you see that's a little bit of a longer notebook. And overall, what I was saying before, this is all pretty simple, I would say plain vanilla Python. So there's no class, for example, that you find, nothing highly sophisticated. So this is really a fundamental thing. So math basics is something that I recommend to study alongside the other materials, but finance with Python for the first 3 weeks is something that you should really focus on. If you don't have time for anything else, focus on finance with Python. This will pay off 10 times, 20 times later on. But that's really important. Even if you say, well, tools and skills like the cloud is something that I'm interested in, just skip that. So here you get the real basics, not the real basics, the basics that are really required. That's a better way to put it in the other parts, right? So therefore, for finance with Python, which is a class which has also a course, meaning a text, you have 2 sets of Jupyter Notebooks, the one that come with the videos and the other ones that come with the text. So there might be quite some overlap, that's for sure, but not necessarily are they always the same. So same holds true here. I cannot change them. I would need to put them in a different place where I can save them, right? So meaning what I was saying, this is the this was the course, and here of course we have the finance with Python course and trainings. Finance with Python training, that's something else than the course, and you see there are now other Jupyter Notebooks, right? There are a total of 6 videos. You should cover 2 modules per week in the first 3. So that's already quite a bit. And again, if you don't have time for more, that's what you should focus on. These are the basics that all the other classes assume later on. And you see many resources that you find on the Quant platform. And I think prioritization and focus is key in this context. But this in particular is a gentle introduction. So don't be afraid to dive into it. This is supposed to be the gentle introduction to our important topic. So tools and skills. This is something that everybody should master as well. Maybe not at the very beginning. We start with it in week 1. So to be clear here. But if you say, for example, I need to focus, I need to prioritize because this week is a heavy week for me at work or whatnot, I would skip these parts and I would then just do the stuff that is possible on the Quant platform. I've shown you that without any local installation, you can get started right away. Just with like 3-5 clicks, you are within your first Jupyter Notebook and you can get started with the first video, etc. But it is important to master these skills. So to install Python on Mac, Linux, or Windows, depending on what machine you use. Some of you might want to do it on 2. Docker usage, for Jupyter Notebook, right? The same holds true. Cloud usage. So we have in the beginning for the first 3 topics, for the basics, for the 3 basic blocks there, we have 2 videos each for the Mac Linux world and for the Windows world, because there's still slight differences. The worlds have come closer, much closer than like a couple of years ago, but yeah, still, I think it pays off to cover these 2 words separately. Then we have the development part where we introduce Vim for code editing. Why Vim? Many might ask, we have X, Y, that out there. Yeah, you can use Vim on all platforms, in the cloud, via the command line, and it's pretty powerful. So it might be something new, but when we cover, for example, cloud stuff, you cannot use Visual Studio to do this stuff directly in the cloud. You need something via the command line. And Vim, I think, is the most powerful thing. Of course, there might be people out there say, oh, Emacs is better or whatnot. We focus on Vim because I like it. That's the major thing. I never work with Emacs. I think it's like when you get into one world, you don't want to change it. And I hope that you will see that there are a couple of benefits. And even if you just learn like 5–10% of what's possible, this brings you already pretty far. Screen, Vim, Q for editing, logging, debugging, doc test, unit test, Git version control, then for distribution, Python packaging, documentation, code hosting. These are topics that are really important. Um, yeah, for everything that you might want to do. And not even, let me say, for Python for finance, but if you want to do some Python programming or development in general. So most of the things that we cover here, this is of course Python specific. Q is Python specific, but Screen, Vim, Git, Cloud, Docker, etc. This is basically independent. Code hosting on GitHub, this is independent of Python. Of Python as a programming language. You will benefit even if you later code some other language, let's say Julia, for example. So there was a question with regard to the books and the text that we have on the platform. They are essentially the same, but there have been obviously changes, editing changes for the publication. But overall, the contents are the same. If you have a look, for example, at Python for Financial Data Science, where we provide a text as well, this is just the first 13 chapters that we provide as HTML. Parts 4 and 5 are not provided as HTML. So there are differences, but the core is basically the same with regard to the books and what we provide in digital form. So what are the major elements here in tools and skills? Jupyter is what we want to use. I've shown it already. Python is powering Jupyter. Of course, these days you can use Julia, what I mentioned before, with Jupyter as well, but Python is what we focus on. Then maybe you want to host this in a Docker containerized environment, and maybe you want to do this in the cloud. And all these different elements and layers are covered in the tools and skills class, right? As before, videos plus resources, and this is a theme that is going through everything that we have. I was already referring to Python for Financial Data Science, and this is based on Python for Finance, but it's only, quote unquote, the first 13 chapters. Python for Finance has a bit more. It has an algo trading part, it has a comp finance part, but these parts are covered much more deeply in the respective core class. So here we focus on the tools that everybody that wants to do something related to financial data science and data-driven finance, as it's called these days, will find useful. So we cover data types and structures, NumPy, pandas, object-oriented programming, visualization, time series, input-output operations, performance Python, right? Still, I meet people every once in a while who say Python is too slow for X, Y, that. I think the use cases where Python is too slow compared to other higher level languages is decreasing. So there are still maybe, let's say, high frequency trading, which is a hardware game where Python might not be the #1 language, but think of large scale machine learning, deep learning endeavors. Python plays a major role, maybe not at the core, but for orchestration, etc. So performance Python, one of my favorite topics. Math tools, stochastics, statistics, machine learning, dates and times, all relevant and important topics for finance, obviously, right? So that's something that you also should study carefully. If you say, for example, input-output, it's currently not that relevant. This week I don't have too much time. You might want to skip it. But for example, the basics here with regard to NumPy, pandas, and OOP, this is really something that you should focus on. And the rest is maybe, as time allows, maybe as you need it, or if you want to study thoroughly, then according to the study plan. Same structure here. It's like finance with Python. We have videos plus notebooks. We have a text, and we have with the text also additional resources. So they are really comprehensive in that you get lots to read, many sessions to watch, and lots of code that illustrates everything that is covered in there, right? So Excel still is one of the most widely used tools in the financial domain, and I think it's a magic combination. If you want to use Excel, and are tired of the limitations of VBA, you can replace VBA these days, I would say, exclusively by the analytical power of Python, right? Excel is a wonderful tool to create fast, interactive GUIs, right? Where you don't need to program web stuff or whatnot, or uh, even worse, desktop GUIs. You simply have your grid there, your sheet, and you have the buttons, and you click the buttons, and then you call. That's the beauty. Powerful Python functionality in the backend, which might interact with APIs and whatnot, and the results are presented in the front end within Excel. So I'm not the biggest Excel fan, but whenever I work with Python and Excel, I think, wow, this is what you all can do here within Excel, and I think this is how it was meant back in the days, right? More like a GUI and not like a complete database, calculation engine, simulation engine, whatever people do, portfolio management, trading engine, right? That's not really the purpose of Excel, but it excels at easy and fast GUI development. Python for databases, probably comes a point in your life, in your professional or private life, depending on how you want to use it, where you have large data sets and where you might need additional technologies, like maybe an SQL database, MySQL, SQLite, or an object-oriented database like NoSQL, MongoDB, or some other techniques like PyTables or SQL Alchemy, which is an abstraction layer for SQL-based databases, or BCode like columnar data store. So there are pros and cons for every such technology. Our focus is on really doing or covering the basics, and then compare the different technologies with regard to efficiency, with regard to storage use, with regard to speed of storing and retrieving data, of implementing calculations, so that you have a good comparison of A, what is available, and B, what the major benefits and drawbacks might be. So this is something that is supposed to be in the cloud. So you should have covered the basics of the cloud, etc., in order to set everything up. Because what is required in order to follow along this class, shouldn't be installed on your local machine, because you might easily mess up with what is going on. But we teach you how to set up everything in the cloud, and then we provide you the resources here to install everything that is required to follow along the Python for databases class. Natural language processing. I said it already, as it stands, it just has two modules. And so far, I must confess, we are a little bit or often demand driven. If people ask, or if 5 people ask me the same thing, I'm usually inclined to cover this more. But so far, not too many people have been primarily interested in natural language processing, although it's kind of like relatively easy, straightforward, and powerful these days to use Python, for example, let's say to analyze tweets or whatever text from the web, or news from professional data sources such as Bloomberg, Refinitiv, or Dow Jones, let's say, right? But we provide you here with the basics that you can use to analyze large amounts of unstructured data. The cases that we have, they are easily transferred to other cases, other use scenarios than the ones that we cover. AI and finance at the core of what we do, right? Here on our way to super intelligence, or an artificial financial super intelligence, who know what's on the horizon. So that's the book here. Again, digital text is there, but we cannot provide access to the original book in that sense. Many notebooks, lines of code, lots of text. And here we have a total of 24 module sessions in 2 classes. So there was first, I would say, the basic, our starting class in AI and finance. This focuses more on building, for example, neural networks from scratch. So this is more look behind the scenes. The other class, which is called AI in Finance book, when you have a look at the study plan, this is based on the book and thoroughly goes through the resources and the topics of the book. So you have a total of 24 module sessions in 2 classes. So many things to cover. There are some redundancies, that for sure, but as we know, repetition is what makes us better. So I don't consider this to be a drawback, but rather a strength in this context. And you should study this carefully because the topic is so important these days, right? We cannot speak against it. And as a special topic, which is covered separately, we have reinforcement learning in finance. And I was so intrigued when I first read about a gaming bot playing the games of Atari 2600, right? Not with a physical robot holding a joystick or something, but rather via an API. Of course, we are in the world of APIs, and this was what really got intrigued me in combination then later on with AlphaGo, AlphaZero, and all these stories you probably have followed along. And we cover, and basically that's the only place in our program where we cover games, but this is usually the starting point for reinforcement learning, for which you then move on into other areas such as finance. So we cover the card pool game from the OpenAI gym environment, a mountain car, a lunar lander. These are the 3 examples that we cover in that class. And here there are links to videos behind that. So let me maybe open that. There is a video recording. So I've been playing this game when I was younger, much younger, when it came out. And in this class, we program a bot which learns how to fly the spaceship. There are basically 8 choices, 8 actions that the agent can choose from, and it should learn to land without crashing the spaceship between the 2 yellow flags, slowly enough, right in the middle of it. And you see here, this is a successful try, but it's by far a good agent, a good bot, because it takes quite a bit, right? It's like, you know, somebody who does it for the first time. Oh, I'm careful. I'm not sure what I'm doing. A better bot probably would have landed this thing already 30 seconds ago, but at least the recording here shows it is landing softly and in the middle of it, and it comes to rest, and this is now considered a success in the game. And yeah, you will be able to do that stuff on your own and learn about Q-learning, reinforcement learning, which you can then transfer to the wonderful world of finance, right? So what is that here with the, because I clicked on, maybe I need to reload it. Something got stuck there. So yeah, in our class, and the subtitle here, you see it's from playing games to trading in the financial markets. We cover these, we cover the basics, we cover these games, game environments, as they are called, right? And then we move on and go into the trading world, where we develop trading agents, trading bots, right, that learn from interacting with the markets, and then they also are equipped with functionality to trade in the markets, right? Now we are coming to the 3 core classes. Again, I don't want to spend too much time with the single things. It's again about the broad overview, about an introduction. It's based on a book these days, but the book is an outgrowth of what we have been teaching over the years. And there's quite a bit more, as I said before, beyond what is covered, for example, in the book. So more trading platforms, other code, many more examples, going much deeper, for example, with regard to Wanda, where we have a Wanda masterclass. And again, there's a bunch of resources around the core stuff. So the foundations, here I emphasize it, but this holds true even more so for Comp Finance. This holds true for Python for asset management. It is like finance with Python, finance with Python, and finance with Python. In the beginning, again, if you don't have time for anything else, just focus on finance with Python. Then you learn here to vectorize backtest strategies, how prediction-based trading works. So at this point, you should already have seen many different techniques in the AI and finance modules that are applied here. Event-based backtesting is covered. Then algo trading itself, so how to deal with real-time data and streaming. The Wanda trading platform, FXCM, interactive brokers, and Gemini are covered. And last but not least, here some case studies. Also here, as an example, the experience phase with the practice module 1. Your own strategy should be developed, not for, let's say, making huge profits, but that you come up with your own idea, you backtest it, you decide for your strategy, you do the first test runs. Then in the practice module 2, it's about deployment. You should try here to deploy it, let's say, for 2 days straight, right, without stopping the code, restarting the code. So this is about deployment, and then the final project, the research paper comes. So for the other two core topics, Comp Finance and Python for Asset Management, it's similar. There's a practice module 1, a practice module 2, and then the final project. Of course, the practice modules are about different topics. So here is my pyramid, which I use since years, and I haven't seen any reason to change it. We start with the infrastructure. Financial data is what we need. Strategy is what we want to develop. Backtesting is what we need to judge the strategy. We need to connect to the markets in real time to be able to trade. Then we need trading functionality, capability, trading code, right? And last but not least, automation. So that's, for me, these are the 7 steps in algorithmic trading. Maybe there are many more sub steps, but I think these are the major ones. And if you then go on and go into the Wanda masterclass, there are many more details where we cover Wanda more comprehensively as compared to the core class. Because I think for retail algo traders in particular, to learn all the elements of what is important there, Wanda is from, I first used it, I don't know, 15 years ago. It's still best in class, if not the best, to get started as a retail trader. I know there are many jurisdictions where you can do full-fledged trading, meaning real money trading with Wanda or O&A. I'm still unsure whether it's Wanda or O&A, some people say. I say Wanda, for me it's more easy. But it's first about learning, right? And you should first focus on technology. And only secondly, I always get these questions. Yeah, but I've been doing day trading with interactive brokers. Can I do X, Y, that with interactive brokers? And then often I say no, because they don't have the technology, or it's too difficult, too cumbersome. If you want to do cloud deployment for interactive brokers, basically it does not work, period. So where's the point in trying to do it if it simply does not work? I mean, there are workarounds that theoretically work and practically somehow work, but you need like a team of engineers who keep up that. But with O&A, with Wanda, with a few lines of code basically in the cloud, when you know how to set up in the cloud, you can get started trading within hours and not within weeks or months maybe, right? So that's the difference. So technology first, important message, and platform and products second and third, right? Yeah, for backtesting, we have different methods. In some areas, we also use Monte Carlo simulation, but not primarily in the backtesting of the algorithmic trading strategies, because I still need to see like a major use case in this context. For example, we use Monte Carlo simulation in the context of reinforcement learning, so that we have many runs, maybe 100,000 runs for the trading bot to study and to be trained on. But for the backtesting, you need real data. Where's the point in testing a strategy based on fake or simulated data? But that's my opinion. I'm always open to pointers to papers or insights that say otherwise. Python for computational finance, mostly based on my book, Derivatives Analytics with Python. Here we do not provide the text. It's a Wiley book. For LLVD, I'm doing it, but for that one, not. But we provide many excerpts out of the text in the Jupyter Notebooks. So that's kind of like a compromise, and that's like the Chinese version of it, if you're wondering, right? Of the book. Here we cover market-based valuation, complete models, risk-neutral valuation, Fourier pricing, American options, general market model, Monte Carlo simulation. For those of you who have some connection to options and options pricing, you know what it is. If you have never had any exposure to the option markets, probably you haven't opted for that, or you will find maybe a good entry point here based on Python with our classes. Then we have a separate class, listed volatility and variance derivatives, a very important asset class these days, right? Um, and yeah, here the Jupyter Notebooks, they provide basically all the text. So the books provided A, and B, the book chapters are or have been originally Jupyter Notebooks, and I provide updated versions as Jupyter Notebooks with all the text, so code and text like the book really looks like in the resources. So here we cover volatility with the VSTOXX index, but the VIX is basically the same. This was here driven by a cooperation with Eurex, our European derivatives exchange, with the Eurex stocks and VSTOXX, right? We cover variance products like variance swaps and variance futures, and we also cover how to value all this with DX Analytics, our open source package. Speaking of DX Analytics, this is another part of the Comp Finance class. So there are basically three classes: the core class, Comp Finance, then the LLVD class, specific for volatility and variance derivatives, and then another one, the third one for DX Analytics, right? Our open source package. You can go to the webpage DX Analytics or dx-analytics.com. And you see the topics are almost in line with what is covered in the core class. So in the core class, we show the math, we show the finance, we show the Python code, and here we show how to do everything that we do in the core class and quite a bit more based on the package. So a good grounding in computational finance part is helpful to do it here. But on the other hand, if you don't want to go into the math basics, the finance basics, you can still use DX Analytics, even if you don't master every single minute detail of the other part. So this is just a schematic view of DX Analytics. So forward simulation, Monte Carlo simulation of the cash flows, backwards induction for optimal exercise policies, non-redundant orthogonal modeling of the risk factors and the derivatives themselves, then composing positions, and then a portfolio of the positions. The risk neutral discounting can happen based on a constant deterministic or stochastic short rate, but the details again in the DX Analytics class. I must say that's like A is the largest open source package we have ever open sourced, and I think it's also the most powerful in the finance part. We do not even cover everything that the package can do for you. Here the pyramid for with 8 elements, 8 steps for computational finance. It all starts with infrastructure and data. Without that, where's the point in doing finance, right? We cover models. Simulation is at the core because Monte Carlo simulation is the most powerful technique in this area. Fourier pricing is used as an efficient mechanism for plain vanilla options to be priced for calibration purposes, right? Not for valuation, because the focus is more on exotic and American ones. Market valuation is when we then have a calibrated model and apply this to whatever payoff structure we find in the market. And last but not least, hedging, of course, is an important topic in this area. Python for asset management. Here we cover the basics of risk and return in finance, mean variance, portfolio theory, capital market theory, like capital asset pricing model, arbitrage pricing theory, then alternatives to MVP theory, risk budgeting parity, based on coherent risk measures, etc. And also what we introduce here is a combination of AI machine learning for asset management. And we also have stronger focus on the Black-Litterman model, where we can incorporate our own views, be them subjective, individual, or be them created from machine learning applications in this context. Again, no text here, but maybe in the future, I don't know. I was asked already to write a book about Python for asset management. I think it's a large market. It's also Python is a pretty powerful language in order to tackle basically all the issues, all the problems that you face in asset management, right? But you have here a total of 17 modules, 1.5 hours each, and many Jupyter notebooks with A, yeah, set examples, and B, also demos, as they are called, where I in the sessions develop code on the fly, so what we call live coding, but where you see basically line by line how the stuff is developed, which is also pretty useful. And you might want to try later on when you've watched this and study it to do it in the same way. So I think it's basically the best way to get started on your own, that you watch something, right, and you internalize the basic elements, and then you try it on your own. It's like listening to your piano teacher playing a certain score, and then you listen carefully, you watch carefully, and then you try it on your own, and later on you can then maybe buy your own scores and play different music pieces, etc. So same for coding, right? Think of it as a skill, not as something that you really learn. You need to internalize. Your body and mind needs to internalize. So portfolio selection, getting back to the 50s, maybe the first quant model that we ever had. And here I'm having three major sources. So for the starting from the right side, AI and finance also plays a role here. I said it's at the core of basically everything these days. Not that much yet in comp finance. Then Python for finance has many elements that we revisit here in the class as well, or make use of and leverage in the class. And I have found, although the title might be a little bit misleading, but it's not only an introduction to risk parity and budgeting, this book by Thierry Roncalli. It's also a good introduction to the standard theory and in particular to the risk measure, and it's a huge reference book. So when I started this class at the beginning of 2021, I was looking for proper references, and from all the references that I've checked on learning.o'reilly.com and all the books that I've had look at live or printed, this one is the one that I like most. It's kind of technical, but it's comprehensive and thoroughly written. It doesn't have any code. They are not like the book that I mentioned before, Python for Asset Management or Asset Management with Python. It's not yet around, right? So we need to mix up things here. The basics in the middle, the theory on the left-hand side, and the AI elements on the right-hand side. And yeah, that's currently what I would recommend there. So case studies and demos. I have shown already the Quant Platform, but I have said that you should be able, based on the tools and skills class, to set up your own environment. And again, lean back, don't try to follow along. That's not meant here as an exercise for you. This is just meant for you to get an overview and to whet your appetite. And Python with Docker is something that I like to show because if you haven't done so yet, probably many of you have, maybe some of you haven't, to set up an infrastructure, Python is not too difficult. So here on my machine, of course, I have some Python, right? When I type Python, it says Python 3.992, packaged by Conda Forge. The version here, it's quite a bit old. Maybe I should update it, but for me, it all works, right? And I can do print, let's say, hello Python for finance world, our hello world example, right? So this is of course available on my machine. It would be, I think you would be surprised if I wouldn't have Python installed. So therefore, in order for you to show how to set up something from scratch, I'm going with a Docker container. If you haven't used Docker, again, don't be too aroused at this point. Nothing to fear, nothing to be afraid of. We cover all the details in tools and skills. So I use Docker. Now, where do we go here? I use Docker now to have locally a Linux environment, which is basically blank. What do I mean by blank? So I mean the following. I'm here in a Linux environment, so Docker container on my Mac Linux. I go to the root folder. There is currently just this one folder mounted. Right, there are the examples that I'm going to show later on, and I also show the link to the gist. But here in this environment now, in this container, when I type Python, there is no Python whatsoever, right? Later on, we are going to use intensively IPython either, right? Or Python 3. No, none of these commands work, which means I now have a blank, Python blank environment. Therefore, I first do some housekeeping. I update the package index. I update those packages that need some updating, and now I'm good to go. This means I can install, for example, tools like wget. This is a Linux tool, a small, simple one. It does one trick, and as usual in the Linux world, tools often do just one trick, but they do it well. And the trick of wget is to retrieve removed files, and I recommend in general to go with Miniconda. So here the Miniconda download page, latest Miniconda installers, right? You see here Windows installers, Mac OS installers, Linux installers. So on my machine here, which is a Mac with a M1, so Apple Silicon, I would need to go here, for example, Miniconda, Mac, Apple, M1, ARM, 64-bit bash. But I'm now in a Linux world, right? So I need to look here at the Linux installers, Python 3.9, and yeah, M1 is an Arc architecture, Arch here, you see. So I copy the link address here. Again, this is all explained in detail in the tools and skills class. So I don't have anything here beyond my folder live, and wget, I'm now retrieving the installer. The installer is there, and we see it has some 65 megabytes. So that's quite a bit, but it's Python plus a couple of batteries included. So I need to execute this now, bash Miniconda, and it says, welcome to Miniconda, blah, 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 and I continue. So now I can, and you should read through this carefully. All right, so going through this, I accept the terms and conditions. Miniconda 3 shall be the target folder. I'm fine with that. You can change this to something else. So usually on my Macs, I call this these days simply Python. Running conda init, yes. And now we should have Python available. Let's check. Python. Oh, it's not there. Yeah, there's one thing that I need to do. I need to restart bash. And suddenly you see that my prompt here changes, right? The prompt changes to base. And this indicates now that we are in a conda environment. And when I type Python, oh, I have Python 3.9.5 from May 2021. And I can do the same thing here, print hello all. And that's my first line of Python code. And you saw it's pretty straightforward, and the same procedure basically works on Windows and Mac as well. I'm doing it here on Linux, but this works. And I'm doing it here in the container. And if you are maybe, let's say, on a cloud server, on a droplet from DigitalOcean, the same procedure applies. So once you master the basics here, then you should have an easy time no matter what the platform is. So I don't have that much stuff already installed, but I will need more, like Ipython. I said before, Ipython is something that I use often. You probably would use it also. So I can go and install, let's say, Ipython and NumPy at the same time, right? So shall I do it? Yeah, looks all good. I confirm. And it's now downloading. It's now downloading the packages, extracting them. And we're good to go, hopefully. Let's check. Ipython, yeah, there's Ipython. And you see, immediately we have a bunch of advantages. We have a numbered input, and we will see output prompts. So an output prompt is not here, right? But for example, 3 plus 4, when I do some math, there is an output prompt, out2, red, green. So we have syntax highlighting and many, many more things. So we have tools and skills special about Ipython. Ipython is used in many other instances, etc. So it is much more powerful than the regular prompt and environment that we have seen already before. Let's check whether we have NumPy. So from NumPy random, import default RNG. That's the new way of doing it. RNG default 100, maybe the seed that we set, and RNG random 25. Let's say that's enough. So you see, it wasn't that much effort, and we have Python installed. Now we have Ipython for the command line. We have NumPy, which is so important for us in finance and to this and any other scientific discipline. And we could now go on and install Jupyter Notebook, start up Jupyter Notebook. That's all kind of straightforward. You just need to internalize a few major steps, and then I think it becomes second nature. So I have got, and that's feedback that really makes me proud when delegates towards the end of the program say, well, the best thing was I was really afraid of your infrastructure topics, and I've never worked in the cloud. I have heard of Docker, but I've never used it. Now setting up these infrastructure and dealing with them feels like second nature. So this is really what makes me proud, because these are wonderful technologies, and we as individuals sitting just with our notebooks here or desktops, be it Windows or Mac or whatever, we can leverage these techniques like back in the days, let's say 10, 15 years ago. They have only been available to the big companies, the big financial institutions with millions and millions of budget. And if you ask, there was a question whether you should go with Anaconda or Miniconda. I always say the same thing. Under the hood, they use Conda as the package manager, but Anaconda comes as like a huge installation with 150 plus packages, 125 of them you will never use in your life. So for me, it's like a big garbage can where there are just a few variables in there. So I like to start with Miniconda and then just add the packages that I would like to have. Why should I have 120 packages or 100 packages or 80 packages on my machine that I never use? This also leads to problems with regard to dependencies, that you update maybe one thing and this requires updates of other things and vice versa. There might be conflicts with what you do and what other packages require. So I don't want to speak against Anaconda. It's the easy way to do it once and for all, probably not, but you do it once and you have it all. But all is 10 times all you would need in order to do the stuff that we do. Right? So I recommend building these things from scratch and to learn the trade and to know exactly what you do, what you want to use, and what you then have on your machine. We also cover like setting up environments for different purposes, etc. Yeah, and then the problems are exaggerated if you have 3 times the stuff that you don't want to have. So that's the go-to resource. You find this link also in many different places where you get all the Miniconda installers, and it's much faster and more efficient, and it saves you headaches and space. Right? So crypto basics, just an example which I'm still really excited about. So here in crypto, for example, I show how to use Hashcat to crack passwords. Now you might say, oh, crack password. Yeah, this is not meant to be like black hacking, right? With a bad intent, but like white hat hacking with a good intent, because hashing is such an important approach, technique in the whole crypto space that I put a bit of emphasis and show different approaches. And Hashcat, according to their own words, is the world's fastest password cracker. And how does it work? Yeah, so here, installation, you skip that, please. We cover this in the class in detail. If you're curious and know what you do, you can follow along the installation guide. So first, I might need to have a hash code. So a very simple password for me, myself. So you see, I'm pretty egocentric. My wife regularly says I'm egomanic. I don't know. But here you see the password that I've chosen is simply my first name, Eve, and many people use that. Maybe the first name of their kids, so it would be Henry and Lily in my case. So I don't use them, so I can speak about this. Hopefully here, let's assume this will be my password, my first name lowercase. I create a hash code, and you see the hash code is something much longer, and we have numbers and characters, and this is in hex format, so hexa decimal numbers, so 0 to 16 instead of 0 to 9, or 0 to 15, depending on how you do it. We have 0 to 9 plus A, B, C, D, E, F, right? And the same holds true for Eve 2. So there is now like one more character, and you see the same length. So that's the major characteristic of a hash function. No matter what you pass to the hash function, the output is always the same. And of the same length, sorry, it's not always the same. So there are two things that we need to distinguish. The length of the output is always the same for the same hash function, and this is a deterministic function. Sometimes in the press, let's say in the Financial Times, whether it's maybe a writer and editor which is not that tech savvy, they write these are random digits or whatnot. This is not random. This is a deterministic function, right? When I pass it the same input, it gives me the same output. It's not random. It looks random, but it isn't for sure. So that's the characteristic of a hash function. And the third major characteristic, so same length, deterministic. And the third thing is that it should be impossible. It should be practically impossible. Theoretically, it's not. It should be practically impossible with the available compute power to get from the hash code to the original input. That's like, right, that's the major thing here. And in databases, passwords are stored, should be stored as hash codes and not as plain text. Although, you read like still on a weekly basis from recent cracks. So I write these two hash codes into a file here, so hashes. So these are now the two hashes that I've written. This might be my little database, right? And oh, here it is, right? And now I delete like recent hashes here. This is just a technical point. And I have my hashcat installed here, which now gets started based on the hardware that is here. You see Apple M1 just uses device 1, right? And it now does what is called a mask attack and goes from 1 to 2 to 3 to 4 digits. And this was pretty quick here. To crack these two passwords, like by brute force, by a mask attack, this took like 6 seconds only. And I can show here the passwords with the parameter show, and you see this hash code is Eve and this hash code is Eve2, right? So therefore, you shouldn't, that's one of the reasons you see here how it works. You shouldn't choose passwords that are too short. So many websites require you to have like, I don't know, 8 and minimum of 1 number, a minimum of 1 special character and so forth. So that's the reason, because otherwise it's too simple to judge the passwords. Right? Yeah, thank you for pointing this out. There are more characteristics of hash functions, like the collision probability should be negligible, should be close to 0, and should be puzzle friendly, which means that when you do small changes, the hash code shall change in a way that is not predictable, right? It's not like that you say, well, just like fine tune it a little bit and we are narrowing into something, right? So, and again, we cover the details in the class there, right? So now random hash codes, let's crack a few more, just that you see, even if you have something like JQURAB, I don't know, it's hard to remember, but still, I think we can, all of us can remember this, maybe 2 or 3 digits more, 66LZL1, but I'm just using lowercase characters and numbers here, right? I write this now to the file, right? So I now have now a few more in there, right? You see now the list has grown, and when I now go and do the same thing, it's now going from 1 to 2 to 3. You see 1, 2, 3 characters in combination. That's all going fast. And here already you see it has cracked the first 6 passwords, and it's going at the speed of 63 million kilo hashes per second. So that's like 63 million hashes that are checked per second. So this took like 15 seconds for it to crack the new passwords here. See SP, right? So, and now a large character set. This is now where we get closer to more secure passwords, but I keep it pretty short, because if the character set is that large, you see this is now the whole character set, lowercase, uppercase, numbers, and special characters. Now the combinations are, I wouldn't say endless, but there are plenty, right? So these are now the ones, and it takes quite a bit just for the maximum of 1, 2, 3, 4, 5, the maximum of 5, right? Here to be cracked, so much longer than before. So therefore, again, you see here, you learn why to use characters, why to use a combination of lowercase, uppercase, and so forth. So this is not, again, for teaching, it's just to whet your appetite what we cover here in Crypto Basics class, right? Yeah, and again, a question, for everything that you have signed up for, you have indefinite access. So what you have access to right now, you will have access also at the end of next year, or whatever, right? But what I was saying is, maybe we come up with something new in the future, which wasn't part of your package that you've booked, and then you might not have access to that. But I think this is how life goes in general, right? But to your resources, even when we have updates, you will have indefinite access. Yeah, then we have efficient markets. I don't want to wait this out until this has cracked the passwords. Efficient markets are important for all the core classes. What do I mean by efficient markets? Yeah, I'm speaking here primarily about the theory of efficient markets, right? And the work on this, the theoretical and empirical work, dates back to the 60s, particularly the 70s and 80s, where famous finance people, professors like Eugene Farmer and Michael Jensen, have been working on this topic, right? And what it says basically, and I want to highlight this here, for example, we shall see later that if the random walk, and for our purposes, I treat efficient markets and random walks synonymously. There are slight differences in the concepts, but I treat them here for the time being synonymously. So we shall see later that if the random walk theory is an accurate description of reality, then the various technical or chartist procedures for predicting stock prices are completely without value. Yeah, this means that all the people around the world that sit there and watch their charts on a daily basis are doing useless things. But it's not that Pharma says that's the case. The message is, if it holds true, what is pointed out in the theory, then it is without value. And the same is, 13 years later in a paper by Michael Jensen, a market is efficient with respect to an information set S if it is impossible to make economic profits by trading on the basis of information set S. That's a little bit more modern, right? So we have an information set S, and this can be as large as we can imagine. Back in the days, this was end of day data for, let's say, the Dow Jones index, just to name a reference index, right? And that's it, maybe going back 20 years. So, but today, of course, we have high frequency data, we have data from around the world, we have whatever data, fundamental data, whatever. So S can be pretty large, and still the theory might hold. So let's make it a bit more specific. So I have data here Apple, Microsoft, S&P, VIX, Euro, US dollar. So I calculate the log returns. I plot the data with cufflinks. You see this is normalized here. Some quantities are mean reverting, some are trending. So the winner here of this game over 10 years was Amazon, here the gray one, right? Amazon. Here we see the log returns as histograms, all but normal, I think we can conclude. We see here the correlation matrix, but this is just for like illustration and visualization. So we now prepare 7 lags for each of the instruments, meaning like a chart analyst would do, going backwards in time and analyzing historical data. We take 7 lags of the price and use ordinarily scarce regression to try, based on the 7 lags, to predict the future price of Apple, of Microsoft, or whatever is in the data set. And what we see is that basically for all the instruments, be it mean reverting, be it something like a VIX, which is mean reverting, Euro, US dollar mean reverting, at least in the longer term, gold ETFs, S&P, the stocks, same characteristics, just the last lag, the lag number 1, yesterday or the last available day, is important for the prediction. Everything else can be basically neglected. And I must say, this is just for illustration to say that the best predictor for tomorrow's price is today's price in a least square sense, meaning we can go back in time as far as we like. Still, what is most important is the current price and nothing else to predict tomorrow's price. And if this is the case, we would conclude that going backwards in time and doing chart analysis or whatnot is worthless, as Farmer was pointing out. And what I'm doing here is I'm using lag data as independent variables, as features, if you like, and they are highly correlated because price data here, right, you see is highly correlated. In that sense, I'm already violating one of the technical assumptions of regression, but it supports a bit the statement. I've jumped over that here, right? Here, in such a case, the best predictor of tomorrow's stock price in a least square sense is today's stock price. And this is what efficient market hypothesis is all about. So when we have a look at the Apple stock price today, there is no value in going back 10 weeks, 10 months, 10 years and trying to judge the value of Apple tomorrow from the last 10 months. So it's enough to have a look at the current price, because that's another expression in this context: the market shall be or is always right. But here we see it technically in a least square sense. The best predictor of tomorrow's price is today's price, or best predictor of today's price is yesterday's price, depending on where you want to get started. And then there are, of course, other methods that we can use, like here from stats models, just to show that there are other packages which provide you with more information, like t values, p values, etc. It's not only what I've used before. So how do we work with efficient markets now? Yeah, twofold. In the computational finance class, we consider efficient markets as our friend. So when we have something like the jump diffusion model by Merton, where we have parsimonious set of parameters that we can choose, we take the prices from the market, meaning from plain vanilla options, and use them, again, efficient markets, our friend, and use these prices that we observe in the market to back out those parameters by calibration that best reflect the market. So we wouldn't even dare to question whether the market is correct or not. Plain vanilla option prices in the market of highly liquid options is what we consider the truth. The market value is a given, and we are interested in backing out the parameters from the market. And this is how we do it. So this is now all technical, right, with the characteristic function. Here's just an example. And we minimize the mean squared error, or the root mean squared error, of our model prices as compared to the market prices. So how does it work? We have the market prices. We have here the market prices for a set of options, right? Puts and calls. Usually I do it against the puts. So sorry, the opposite, against calls. So taking out the call prices, you see them here per strike. And then we define our error function, root mean squared error, and then we go and optimize. Optimizing means here minimizing. We try to find those parameters like sigma, lambda, mu, delta, here in this context, that minimize the root mean squared error for our model values when we compare them with the market values, right? This is a brute force global optimization, and then we might go local and do a local minimization to be, in the end, a bit better. So the error function after the brute force step was 0.96, and then we decrease the error to 0.76. When we plot the values, you see here, just when I show you the upper part, the upper subplot, the model values are the red ones, and the blue line illustrates the market, right? And at first sight, this looks pretty good, but we have differences. Here you see the differences. They are like €1. These are European options, €1. Maximum is minus 1.5, but you see it's unbiased. So we have negative differences, positive differences, so it's really unbiased. With maybe another model or a different optimization technique, we could be better. So here in this context, the market is our friend. We say the market is always right. You can read this in a couple of financial engineering quant finance books. Who knows the or who chooses the martingale measure? The market chooses, for example, in one of my favorite books by Björk, Arbitrage Pricing. Their efficient markets is what we leverage. It's part of our tool set in this concept, right? And of course, everything what we do, this is just a question in between, is recorded, and as I pointed out before, shortly afterwards, a couple of hours might needed for the processing. The recordings of all sessions are uploaded. So in the Algo class, we take the opposite stance. Of course, we want to beat the market, and instead of maybe ordinary squares regression, which was around since 18th century, we might use something that is only available today. Let's say deep learning or reinforcement learning. And here, instead of being good friends with efficient markets, we are like enemies. We want to beat. We want to win against efficient markets. We want to prove that markets are after all, not that efficient, right? And we might have some data, we create certain features, and this is just for me and for you that I illustrate. We might use basically the same things as a technical trader would use, right? I use here, for example, differences between high and open, between high and low, for example, right? I use volatility measures, I use simple moving averages, I use momentum, but I can make the list longer and longer, right? So I have 21 features now, total of 21 features, right? Including the open, high, low, close elements. The length of the data is 15,350. We do a split here into the validation, training, and test data sets, right? I do normalization, normalize and lag it, and now we use modern techniques. I mean, think back, 1965, 1978, the quotes are from that I mentioned before, that I read out aloud. There haven't been that many deep neural networks with powerful computers and cloud instances around. So maybe markets have been efficient in the sense that, given the techniques that have been available back then, it wasn't possible or hardly possible to discover economic inefficiencies. But maybe with newer techniques, you might be able to finally uncover these, right? And here I do use a MLP classifier, which is a deep neural network, so multi-layer perceptron. And I do a vectorized backtesting, and given the data that I use, blah, 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 you see here that the benchmark, it's a Euro-US dollar, loses over the time that we consider here. And my strategy is the green one, it wins. So I have an outperformance here of, this is some -3, plus 5, so a difference of some 8% over the period considered, which is not too long. But this is just to illustrate it, right? And to yeah, give you the message based on code and charts that in the one case we are friends with efficient markets. This is the computational finance case, and basically this is also the case with Python for asset management. And in the other case, for Algo, as traders, we try to beat the markets. We try to outsmart the markets. We try to yeah, prove that not always we are faced with efficient markets, etc. And once you have a strategy that you want to utilize, you might need then a platform to trade on. So I emphasized already that Wanda is our primary platform. And here I go and retrieve data. I connect to the API for Wanda. Right? I have a bunch of instruments, so there is a total of some 120 instruments that I can trade in my account. I have both a paper trading account and a real account, but I'm not getting paid in any way if you sign up with them. That's for sure. So no interest. And for example, I can retrieve data here for Bitcoin in US dollar. When I have a look at it, this is for just last week, right? A few days ago. When I plot it, you might have noticed in the press that Bitcoin has come down quite a bit from 60,000. Here you see it's also high volatility, right? This is still a characteristic, like these movements look more like jumps. Jumps are important in the computational finance case, like up jump, right, down jump, and this might be, I don't know, I haven't followed this intensively, might be something like a tweet by Musk or whatnot, right? So this is how the market is ticking. So just to say here, via APIs, we get lots and tons of data. Historically, with O&A, Wanda going back for their core instruments like 15, 16 years, down to the 5-second level, not tick data, but 5-second level, which is probably enough for almost everybody following along here. And we can then backtest strategies such as a momentum one. Right here, it's a simple momentum strategy where I calculate the log returns, then I take a rolling window and here take the mean of the rolling window, then I do drop an A here, then I check where the momentum is positive, and I go here with yeah, if it's positive, I go long, and if it's negative, I go short. So the idea is if I have a positive momentum, given my statistic, I want to be long. If I have a negative momentum, I want to be short. So that's the basic idea here in this context. And the hit ratio, meaning that the number of predictions correct, is only 48%. But this is something that you will hear me say in the sessions quite often. This is just one side of the coin. It's not too important to have a hit ratio of or accuracy ratio of above 50%. What is important is that you get the large movements correct. So nobody wins the game with getting the tiny movements around zero correct, right? The large jumps upwards and the large jumps downwards. So we have seen this in the data. That's a very good example. So if you are wrong, like in this area here for a couple of predictions, this doesn't make a big deal. It's maybe hard given transaction costs. But if you, let's say, this drop here, if you get this wrong and you say, well, or your strategy says this is a long movement, but it's a short one, this large one, that's important. And if you get all these large things correct, that's fine. So you don't need to win all the small gambles here, but you need to win the large, the decisive gambles in this context. So let's see. Vectorized backtesting now puts a performance measure on it. And here I calculate the strategy performance. You see, oh, it's outperforming by 10%. And this is how it looks. I think this, for such a simple strategy based on a Bitcoin, you see that's not too bad. And before, don't confuse it, what I was showing before here, because the charts all look so similar. This is like October 2018, and this goes to April 2019 here in this chart. But this is for just one day, right? This is starting at midnight, and this is going to 10 p.m. at night. So this is an outperformance during this day here from, what do we have, some 10%, what we have seen before. With the numbers, we see it here, some 10% outperformance during one day just with this momentum-based strategy. The number of trades, of course, plays a role, and now transaction costs might play a role, right? If you trade Bitcoin 205 times a day, maybe this looks too nice, but I'm not figuring in here any transaction costs, right? So this is where the trades are going on. So I'm placing a trade here. So let me quickly open the web interface. My practice account. It says no open positions, but it's loading the data. You see, this takes a bit, right? It's now getting your US dollar in there, Brent crude oil, BCO, and you see this is the position that I've just opened. So on the activity level, here I bought the market, right, for like less than a minute ago. So my position is now open, and this is exactly what I've opened here with this API create order, BCO, Brent crude oil in US dollar. I bought 100 units of BCO. Here is like the whole message that we get back, and I can here, of course, maybe I do it in 2 steps. I can reduce the position, by going short, selling 50 units. So let's check. 100, and it was now it was reduced to 50 units, and then I can repeat the same transaction, selling another 50, getting back, and the position has gone. So just like, and this is sometimes even faster than going here and say BCO and right click and trading and sell, buy. You see there are a couple of steps, just like when you have pre-prepared. You could even do this manually. But of course, this is something that a trading bot should do later on, right? So, and here we can now read like the history of transactions if you want to get all the data. So what is the current price of Bitcoin? When you want to do trading, and you might recall my pyramid, there's one step is streaming code, connecting code. We need to connect to the markets in real time. And here I'm now streaming the Bitcoin price. So it has come down a bit more. So I think the below 40,000 levels, the next support here, next major support is inside. Right, 40,000, and you can stream here. That's all with a free account. That's all a paper trading account. You get streaming data for Bitcoin. I can maybe also stream like 20. It's pretty active, and you can get real-time updates. And that's of course bid ask, right, like for buying and selling and buying. In this context, the bid ask is quite a bit here in this context with ONA. And this is also not available for all accounts and account types, etc. But they recently introduced also crypto trading for the major ones. A really valuable addition, as I might think in this context. Yeah, last but not least, I have spoken that much of machine learning, and here basically that's like, I don't know why this says Wanda trading platform. I don't know. Natural language processing and some basic imports. And you might have been, probably you have been. That's the reason why I'm choosing it on our webpage at one day or another, tpq.io. This redirects to home.tpq.io, and you know here's a little bit of an overview, what we do, and group, technology training, partner for Python and finance and algo trading. There's a bit of text, but you see there is some movement. So there's functionality, there's content, there are pictures, there's text. And now when you want to do natural language processing of such a page, it's not that easy, right? because there's so many elements in there that need to be programmed. And when I talk about need to be programmed, let's retrieve the HTML here. Takes a bit, and this is how it looks from character 1000 to character 2000, right? There's like, there are URLs in there, there's a bit of text, many special characters, right? And we can change this and look a little bit later here in the text, right? This looks the same basically. There's now not even some real text that we can read. It's just like JavaScript, other elements you see, maybe HTML code, etc. And the length of the whole thing, some 225 kilobytes. Now, with the tools that we provide you with, here in particular NLP, that's like simply a collection of NLP related helper functions, right? Among others, we have here some cleanup HTML. And once we have cleaned this up, you see 225K down to 9.8K. And when we now have a look at 1,000, or let's go with 2,000 to 3,000, looks completely different to have this in line. Of course, this looks different. In Python for algorithmic training, for Python quants, bootcamp, data frame, blah, 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 right? And no matter where you jump now, you will see like more or less plain text, right? So let's keep this in line. This was the original, right? Like many special things, tags, links, whatever. And now we have a cleaned up text. So we provide custom tailored consulting, development, and training service to financial institutions. Everybody can read this now. I mean, this is a little bit more difficult. And we can now go and check what words we have in there. So this is then typically called tokens, right? And there are like now tokens like imprint, increase, industry, inspire, instead, institution, intelligence is like a vocabulary. We can now generate keywords like portfolio, notebooks, master, markets, manage, love. I don't know where, yeah, we love something, right? And from the tokens we can also generate. This is usually much better than from raw, right? Because the tokens have been pre-processed. Analytics, browser, driven, finance, Hillpish, Jupyter, market, podcast, project, right? These are now major words. And what I really like is the word cloud. Group source, platform, financial. I think this gives a good overview, like quant, finance, artificial analytics, training, risk, science, algorithmic, Python, data, podcast, book, computational, right? And you see that's, at least to get started with NLP, that's not really rocket science, and we teach you quite a bit more in this context. So also, I think a pretty interesting use case, because Python is, like in many other disciplines of data science and machine learning, AI in particular, is pretty powerful here in the NLP area, right? So let me clean this up, right? And this concludes the demonstration. You find here the link to the gist where the resources are hosted. Maybe let me update this, because I've done a few changes. I'm updating the gist so that you have the latest versions of everything. And here in the gist, right, when I reload this, takes a tiny bit. You see, for example, here the command that I've used to start the Docker container. There is the crypto basics module. Oh, I haven't cleaned this up. This is not a good thing. So probably should have done better here, because there's lots of output in there, which you don't need in the gist, right? Just the first one, right? But it doesn't hurt if this output is there. So, but it's lengthy. AI in finance, right? Efficient markets, friend or foe, depending on the perspective, and other elements here, right? That you can see. But I will take care afterwards that the gist here is updated, right? On the trading platform, just the stuff that we have covered, and natural language processing. So All the resources are available in this gist, and you can use git clone, or you can simply click on download zip, and then you can download that stuff. But be aware, you need quite a bunch of different packages in order to execute all these elements there. Right? Yeah, study plan for the programs. Just some basics you should read carefully. Week 1, intro and overview is what we currently have. Math basics, we continue where in the previous cohort we stopped. So Math Basics 40, we will dive into the wonderful world of SymPy with symbolic mathematics. Crypto basics this week, this first week of the program will be about passwords and how to secure passwords. Financial data science, data types, structures, tools and skills, Python environments, AI in finance book, and AI in finance class. So these are the 2 different ones, right? And whenever you see plus chapter, you know, there are reading resources for some of them, not for all. And again, I think I've said it twice or thrice. I say it for the 4th time. If time only allows to focus on one topic, please do finance with Python. That's the most important part for the beginning. You see, we have here 6 different modules there. You can also cover Python infrastructure, financial data science. You find this in the respective certificate program classes. This gives you the very basics. And of course, again, I know sometimes time constraints, you might move things to a later point where you might have, I don't know, a week off, for example, but don't move these 3 here too far. They are important. I expect you to know everything that we cover there later on in all the other modules. Yeah, and as we progress, you will add to your know-how and a particular skill set more and more, so that whenever there is a new topic, I think it's getting easier and easier with time to master new topics that we introduce. And when we get into the practice phase, yeah, we should be well equipped with sharpened tools to attack all the topics. So what are the guiding principles? Just one slide. So Python first. So sometimes people ask me, how many strategies do you cover? Which strategies do you recommend in Algo? This is a typical question. So, well, we just show examples for strategies based on typical technical indicators, also based on machine learning and AI. But we are a Python first program and also company, right? We focus on the Python side of things. We are not in the business of selling you a strategy, of selling you an asset management approach, of selling you any other tool. We try our best to teach you coding and the implementation in Python for finance, no matter what the specific topic is. So it's also not about the theory, it's the Python itself, right? We try to be as specific as possible. So algorithms used and examples shown are really specific in nature, and they are not meant to provide an exhaustive overview. So it's not, when you read something that we write about a topic, it's not like in a research paper for a PhD thesis, where there is a need to get an overview of all the literature, of everything that has been done before, of sorting this into something. So it's not really research, it's more about examples-based specific learning. And it should also be reproducible. So all examples, basically all examples, are based on static data sets that allow everyone following along to reproduce the results. Right? That's, I think, also a really important thing. We have changed this a while back, and I think so far it's only benefits. And last but not least, it's all practical. So it is for you to acquire coding and other practical skills. That's the main goal. So skill acquisition is indispensable. You need to do it on your own. It's what I was saying before. So you need to get to the board and play chess. Right? You need to sit down at the piano and play a piece of music. You need to jump into the pool and start swimming, right? It's not enough to watch others jumping in the pool and swim, to read a book about swimming. You need to get to the pool and swim. You need to get in a car and drive. So the same is with coding. You need to sit down and do it. So these are the principles that, whenever in doubt with regard to prioritization, what you should do, what you should focus on, get back to this slide and focus on that. And speaking of doing and skills, we have a bunch of review questions every 3 weeks. So after 3 weeks, so you can roughly think of the program with 12 weeks. We have 4 milestones, so every 3 weeks, 3, 6, 9, 12, I consider major milestones, and for every set of 3 weeks you get review questions. Algo trading, comp finance, and asset management, where you can test yourself, check for yourself whether you have internalized the most important topics, right? So that's the one thing. That's more like thinking, maybe writing, maybe going back to some resource where I say, well, I recall X, Y, that, but I'm not sure. So let's check, right? Then we have exercises. Some of them are pretty close to what is covered in the program. Some are a little further away, different, right? Where you need to do some transfer work. And then we have test projects. Some of them are a bit more fun, like implementing a game. Some are, I would say, kind of heavy in the beginning, probably. But this is really to get better at solving problems and to better prepare you for the final project to come, right? The user forum is there for questions, like currently there are open questions here with regard to Algo. Is there any reliable technique to detect trends? That's a big deal and a big problem. Again, we show a couple of things, but I'm not recommending stuff and I say this is good or bad. You won't hear me saying that. I say, well, we have done A, B, C, and C obviously was better than A and B, if that's the case, right? But again, I'm not saying choose from the 10 strategies we've covered. I recommend that you focus on strategy 4 and 7, let's say. So that's not what we do, and you shouldn't expect that from what we do. And there's another question. Yeah, sentiment analysis is also covered in the NLP part. So typical questions, they are now relatively simple to answer. If they are more technical, the user forum is your friend. So you find for the single classes, not for every tiny class, but for the major class like finance with Python, Python for financial data science, algo trading, you find boards. On the boards, you can post stuff. You can attach your code. By attach, I mean really upload a Jupyter Notebook or paste the code. But please, 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 if you don't recall anything from today's session, this is what you should recall. Do not post anything that is like, I have in module 4 of class number X, I have done exactly what you have been doing, but it doesn't run for me, I get errors. Please help. I cannot tell how many such posts we have had in the forum and on the web, you find them. Here are the guidelines. Whenever you want to post something, think of this link, go to the link. We didn't reinvent the wheel here. This is from Stack Overflow. They have millions of posts. We have maybe thousands, but they know it pretty well, and I fully agree to what they say here. So how to create a minimal, complete, and verifiable example. When asking a question about a problem caused by your code, you will get much better answers if you provide code people can use to reproduce the problem. That code should be minimal, use as little code as possible that still produces the same problem. Meaning, if your code is like 500 lines and there's just one problem, probably 15 lines of your code suffice to share the problem that comes up. Complete, it should be reproducible. So if somebody copy and paste the code or uses your Jupyter Notebook, it should run. So the error should be reproducible, meaning here verifiable. So test the code you're about to provide to make sure it reproduces the problem. So please, please, please. We even have this whenever you want to post something new. There's in red, it says first check whether you follow the guidelines for the user forum. And last but not least, this is now more about our community aspect. I'm a big fan of Discord. We have regularly more intense discussions, and we are not doing Q&A, which is the core of the scheduled sessions, but also you can discuss about the program or coding questions, or if you have a hardware question, let's say, do I really need an Apple Mac M1 with an M1 processor, or can I use something else? So whatever the question might be, you can introduce yourself, and the delegates channel is so that delegates can discuss with each other. And in the career channel, I'm planning to post more things that I consider to be helpful for those who are looking for a career in the quant finance industry or looking for a career change. I know many of you are in well-paid and uh, exciting jobs already, but maybe this is not for everybody. So we have also this career part here in this context. Yeah, this brings me to the end to today's introduction and overview session. And you might have noticed I'm really excited and pumped for our next round here together with us at the beginning of 2021. I think these days you get lots and lots of valuable input if you want to master Python for finance, for the financial industry in general. I hope you have a good start. This is always important to get some momentum. I recommend it, if in doubt, on what to focus there. If you have questions, you can go with technical ones, as pointed out to the user forum. If you have general questions, what to focus on, what should I do, I have this problem, you can, of course, also use the Discord server. And usually it doesn't take too long until we get back and help you out. In that sense, again, I wish you a great start. I wish you all the success, and in particular, happy Python coding, because this should all be fun, and I think it will be for all of us involved. That's and see you in the next session. Take care. Bye bye.